first thing to do in this question is get your head around what it's saying. So 12 is a two-digit number such that the number 1 formed by the first digit is divisible by 1, and the number 12 formed by the first two digits is divisible by 2. And then we're going to be building our way up with more and more digits. So when we write our three-digit number down, we need the whole thing to be divisible by 3, the first two digits to be divisible by 2, and the first digit to be divisible by 1. So we're guaranteed that one really. Now, 1, 2, 3, whatever order we put them, will be divisible by 3. So the third digit, it doesn't really matter what it is. We have to have all three in there. However, the second digit to be divisible by 2 will have to be a 2. It can't be a 1 or a 3 because they're odd. So second digit must be 2. Like I said, anything can be the last digit, because whatever we put in will be divisible by 3. And 1 and 3 are both divisible by 1. And so there's going to be two options here, 123 and 321. So two numbers. Right, let's move on to four-digit numbers. So we've now got an extra factor that the whole number needs to be divisible by 4, which means that the last two digits have to be divisible by 4. But before we get onto that, we can still think about the other facts. So the first digit divisible by 1 is no problem. The second digit is going to have to be a 2 or a 4. Right, let's think about the third digit. So, or the first three digits rather. That they need to be divisible by 3. So if I've got 1, 2, 3, and 4, there's no way that I can put 4 in. Okay, the only way I'd put 4 in would be if I did 2, 3, and 4. But then 1 would have to be the last digit, and then it wouldn't be divisible by 4. So it must be that we have 1, 2, and 3 as the first three digits. And what that means is that 2 has to be the second digit, and then 4 will have to be the last digit to make it divisible by 4. I just want to say this again. So we need the sum of the first three digits to be divisible by 3 so that the number made from the first three digits is divisible by 3. The only way we can do that is by doing 2, 3, and 4, or 1, 2, and 3 to get to sum of 6 or 9. Otherwise, it won't be divisible by 3. If we go with 2, 3, and 4, it's not going to work because the fourth digit will be 1, and hence the full number won't be divisible by 4. So it has to be 1, 2, and 3, in which case 2 has to be the second digit for the first two to be divisible by 2, and the last digit must be a 4 to make the whole number divisible by 4. So I've only got to check two situations now, 1, 2, 3, 4, and 3, 2, 1, 4. Now, neither of these are divisible by 4. So there are 0 numbers that have this property. On to 5 digits with the same sort of requirements. Now, for the full number to be divisible by 5, the last digit must be 5. But then we've got 1 to 4 here, and we're going to encounter the same problem as for B. Same problem as B for the first 4 digits. So again, there's going to be 0 numbers that can have this property. This leads us nicely onto the last one. How many 6-digit numbers where we're using 1 to 6 in some order where the first digit is divisible by 1, then the number made up from the first two divisible by 2, and then the first three divisible by 3, and so on. Well, it's clear again that we have to have 5 here for this number to be divisible by 5. That is the only possibility. If I take a look at these numbers, then to be divisible by 2, 4, and 6, these must be even. To be divisible by 2, 4, and 6. So, first and third must be 1 and 3 in some order. Now let's look at the options then. It doesn't really matter which way round I have them. It's all about the second digit now because we need the first 3 to be to sum to a multiple of 3. So if I go with 2, then that would be okay. If I go with 4, then that wouldn't work. If I go with 6, then that wouldn't work either, which means it's going to have to be a 2. 2, 3, 4, 5, 6. We're going to have to put a 2 here. Okay, now what happens? We're either going to have a 1 here and a 3 here, or we can look at the possibility of 3 here and 1 here. Okay, we're getting there. Let me just recap what we've done so far. So the fifth digit has to be a 5, so the number made from the first 5 digits is divisible by 5. There's no other way it could be otherwise. The second, fourth, and sixth digits must be even, so that the numbers made by the first 2, 4, or 6 digits are divisible by 2, 4, and 6. They have to be even, which meant that the first and third digits had to be 1 and 3 in some order. So we then looked at 1 and 3 combined with 2, 4, and 6, focusing on the first 3 digits to make sure they're multiple of 3. The only possibility is that the second digit is 2. We can rule out 4 and 6. So I've just written now 2 numbers down that satisfy this. First one with 1, then 2, then 3. The second one with 3, then 2, then 1. So I'm just left to putting 4 and 6 in. Okay. Now let's take a look at the 6. So for 6, it needs to be divisible by 2 and 3. Now we know that's why we had to put an even number at the end. So it's either going to be 4 or 6 at this point. And we're okay that the whole number is divisible by 3. Otherwise, this would have been a no-go from the start. Because if you add all your digits up, then we actually get 21. So we're okay as long as we put 4 or 6 there. So it all comes back to trying to make the fourth digit such that the first 4 are divisible by 4. If I put 34 here, then it fails because 34 is not divisible by 4. Remember, we only need to look at the last 2 digits of a number to see if it's divisible by 4. If I put 6 here, however, then 36 is divisible by 4. So I'm okay. And then this 4 completes the set. So that is the first number. With 3, 2, 1, if I put a 4 here now, then it won't work because 14 is not divisible by 4. But again, if I put 6 here, then it will be. And I can put 4 here. So it turns out in this situation, there are going to be 2 numbers. Yeah, I really like this because it sort of felt like once we failed with C and D, you might think, oh, there's no way it's going to succeed. Sorry, once it failed with B and C, easy to think it's no way it's going to satisfy or for D because we've got this extra condition for 6 in. But the 6 is what actually makes it end up working. By putting 6 as the fourth digit, then all these other, these other properties are satisfied. Fantastic question. Well done.